Hi, my name is Gareth Spence. I'm standing in ADVA Optical Networking's York campus, one of its key European hubs. I'm here to talk about a new technology, a new innovation. It focuses upon the company's 100G Metro solution and a new built-in encryption technology. To help me with this discussion, I'm joined by one of the company's leading experts in storage area networking, Uli Schlegel. Uli, thanks for joining me today. Apart from introducing this new technology, what is the real core of our discussion?
So we're discussing today optical network security. And also how easy it would be to intercept the data, to steal your data while it's traveling down an optical fiber.
Okay, the whole topic of data security is very, very hot right now. In the wake of Heartbleed and some of these other data security scares, a lot of people are asking about the safety of their data.
Correct.
What does the 100G Metro and its built-in encryption do that really safeguards people?
Well, it's quite simple. First thing is, it's something nobody has seen before, since this is the very first set of optical equipment you can buy doing 100 gig wire speed encryption. And it's also the most robust encryption technology we could imagine built in this set of cards here.
Okay, that's quite a bold statement. I guess a lot of vendors tend to claim that they're the first to market, but that is an actual fact that ADVA is the first vendor here with 100G Metro encryption.
Exactly.
Okay.
So also, the design goals of these cards, we first wanted to have it as protocol agnostic as possible, so you can basically run everything. If it's InfiniBand, if it's Ethernet, if it's fiber channel, it doesn't really matter. Secondly, we tried to be as protocol standardized as possible, so you could also feed the outcome of that card, the encrypted outcome, into a standard carrier service provider's network, which is capable to transport 100 gig. So you could use that set of boxes to do end-to-end encryption over a wide area network easily. Third was to bring as much as data rates inside that card to be able to transport it by that card from a client perspective. And that means you can do 5 gig, you can do 10 gig, you can do 16 gig, you can do 8 gig, 40, even 100 gig. It's possible just with one card. And last but not least, fourth one is that it's very, very low in latency, because this is the enemy of all data center applications.
Okay, so those are 4 huge cornerstones right there. Talking about the last point you made, latency, can you talk a little bit more about what latency it adds here?
The latency which is added actually by the encryption, so if you would compare the encryption of this card, the latency of this card with the latency of another standardized card, would be just about 150 nanoseconds more.
Okay, and what does that do to the throughput?
The data throughput is not affected at all, so we can guarantee full wire speed, we can guarantee full throughput and lowest latency with that modules.
Okay, that's a great introduction. Can we dig a little bit deeper now into the demo itself? What are we looking at?
Okay, what we do here is we have the sender is transporting a video signal over the whole fiber infrastructure, over all the modules to the receiver side, and we have here an intruder, a hacker, which will be able to have access to the data while it's transported using this little device here, this fiber-optic coupling device. And I just want to explain a little bit more how this works. And for that, I'm using such a fiber laser here and a standard single mode cable, as you can see. And I'm bending this cable a little bit around my finger, and you can see how the light is coming out of that fiber. And this is how easy people can access light traveling down a fiber, even if it has a cladding and more.
Okay, and what we see there, that's the company's mission critical data.
Exactly.
Wow.
And this is just easy to intercept. And what the device here on the table is doing is exactly the same. It uses a bare fiber, you can see the bare fiber here, and bends it a little bit. And the light which goes out of the fiber, which leaves the fiber, will be amplified and decoded by this system. And just to show how easy it is, Gareth, just close this device and people can see exactly what's going to happen in a moment.
Okay, wow. So almost instantaneously, the intruder intercepts the data.
Exactly.
That's amazing. Presumably though, now that this data is being intercepted by a hacker, an intruder, surely alarms would be sounding, there'd be some type of notification.
Yeah, unfortunately, there are rare systems which are able to detect a little bit loss of light within a fiber, and they usually do not sound an alarm on that. There are systems, but you never know. I mean, such kind of a device or a similar device could be built in your fiber plant from scratch. So you would never know if your data leaves the fiber somewhere.
Okay, and these devices, are they very complex? Are they very difficult to get hold of? Could I buy one, for example?
Actually, those are built for telephoning or doing a telephone conversation over a bare fiber when people installing fiber plants. So you just can Google them up and you will find them in the internet and you buy them less for €1,000 each.
Yeah, I did actually Google earlier today as well, and I found a guide, a step-by-step guide on how to do the whole thing. This was amazing that it's so accessible.
Yeah, it's quite easy nowadays to get access to such data on a fiber.
Okay, so here we can see the data being intruded. There's no encryption involved at the moment. And what we're going to do is we're going to take a slight moment just to pause. Uli is going to turn the encryption on his laptop, and we'll be right back to see what the impact of that is. Okay, so welcome back. It's been about 30 seconds for Uli to turn on the encryption technology. Now, Uli, could you tell us briefly just what you did there on your laptop?
Okay. I turned the encryption on the sender and on the receiver, and what happens then? The key for encrypting the data would be exchanged. So for this small part of time, which is less than a minute, the intruder and the receiver will have a still picture, and after the encryption kicks in, you will have the sender and receivers showing the same, but the intruder is not able to see the data anymore. So the device is closed, the video is shown on the sender and the receiver screen, the intruder is not able to detect, not able to de-encrypt the data.
Okay, so as you said, we can see that the sender, receiver, they're in sync, but the intruder has been frozen out. Regardless of what they do now with their coupling device, they have no access at all.
They have no access at all, yeah.
Okay, could you talk a little bit about the encryption standards that you're using here?
So the technology behind what we're doing here is the wire speed encryption is based on an AES 256 algorithm, which is one of the most robust algorithm in the industry. And the key exchange for doing that, so we have to exchange the keys between the sender and the receiver. This is done by the so-called Diffie-Hellman algorithm, which uses also a key length of 2048 bits for exchange, for having a secure key exchange.
Okay, I was speaking to a member of your team earlier as well, and they were keen to highlight that one of the main focus points here is the separation of the network management from the encryption management.
Okay. This was one of the key points in terms of our software suite doing security. That means if you are using that environment, for example, for a service provider or a carrier, they can use their standard processes to set up the boxes to make the optical link working, and then the crypto officer, possibly from the company using that encryption, could type in the security passwords and could administer the whole security. So this is completely separated from each other.
Okay, and in regards to the in-flight encryption, I've heard people talk about checksum and payload. What stands this apart?
Here we're doing encryption at the lowest possible layer, which is on layer 1, whereas other people encrypt on higher layers. That means we encrypt everything which is coming into the client ports. For example, Ethernet, we encrypt the complete overhead, we encrypt even the interframe gap, we encrypt everything which is coming through those ports. Where higher layer encryption are just encrypting payloads, so the intruder could still get a clue what's going on the network.
Wow. So with this solution in your network, you can have complete peace of mind that your data is secure and where it needs to be. There's no interception.
Exactly, that's correct.
Okay, fantastic. Uli, thank you for talking to us today. If you'd like to know more about ADVA Optical Networking's encryption technology, please visit www.advaoptical.com.